Hello, everybody. We're starting with Cambridge ASNA Level 9709, Paper 4, Variant 2, October, November 2025. Uh, the same piece of advice I'll give you, which I normally give, and that is do not watch this tutorial as if it's a movie. Watch it as if, you know, uh, try it on your own, make mistakes, and then watch it to check where you've made mistakes. Because if you're not spending more time thinking about the question, you're not really learning. So that's it, and I think we'll start. Question number one. The diagram shows a displacement time graph for the motion of a particle. The particle starts from rest at a point O. So let's say this is point O. The particle starts from rest. These keywords are really important. When it says the particle starts from rest, which means um, you can instantly tell that u is equal to 0, which is the initial velocity, and travels with constant acceleration of a meters per second square, taking 4 seconds. Now this is important. So, which means we're talking about this part of the motion, t equals 4 seconds, to move a distance of x meters. It moved a certain amount of distance, and that distance is x. I do not know the value of x as yet. The particle then returns to O with a constant speed. So we're talking about this part of the motion where it's returning to O with a constant speed of 40 meters per second. So in this part, the speed is not constant. Why? Because the body is accelerating. In this part, the speed is constant because the body is not accelerating. Right. Over a period of 2 seconds, so this time is 2 seconds. Find the value of x and the value of a. I'm going to use this part of the motion, right? And this is really simple now because during this time, speed is equal to 40, right? So you know the speed, you know the amount of time it took, you can work out the distance, right, by using a really simple formula, which is, we know that speed is equal to distance divided by time, right? Speed we know is 40, distance is x, and the time traveled is 2 seconds. So x is going to be 80 meters. That's the amount of distance it traveled in 2 seconds, right? So the value of x is 80 meters. Now the next thing we need to find out is the value of acceleration. Now for this, we'll consider this part of the motion, right? And think about, write down your knowns and unknowns. So you need to find out the acceleration, right? You know the initial velocity is 0 because the body started from rest. You know that the distance it traveled was 80 meters, right? You know the time it took is 4 seconds. So can you think of which equation of motion should I use that would take these as inputs and give me acceleration as the output? I think this one, right? So let's use it. We know that distance is equal to 80. So I'm going to put 80 equals, initial speed is 0. So 0 times t plus a half. I need to find out the acceleration. So acceleration is going to be a, and time it took was 4 seconds. So I'm going to put 4 squared. I think it's really just 2 steps away now. 80 would be equal to 0 plus 1 over 2 times a times 4 squared is 16. And that is going to be 80 multiplied by 2 divided by 16 would be equal to a, which 80 times 2 would be, oh, you can just work it out. Acceleration is going to be 10 meters per second. Do not forget to write the units. Acceleration will be 10 meters per second squared. As simple as that. Of course, you can tell 3 marks. Right? I hope you understood this. Let's move on to the next one. A railway locomotive of mass 240,000, it's quite a heavy locomotive, is towing a coach of mass 36,000 down a hill. Okay, so we have a hill, right? And okay, these keywords are really important. Is towing down a hill, which instantly tells me that the direction of motion is going to be down the hill, right? That is going to be the direction of, this is the direction of motion. We have two bodies, a railway locomotive, and that is towing a coach. So let's draw. I'm going to represent it by using L. That's a railway locomotive, and that is attached to a coach. That's a coach. And then moving down a hill. The hill is inclined at an angle of sine 0.04. So we know how to work with this. Uh, the theta, which is really the angle, is sine inverse 0.04. You can move sine over to the other side, so that is going to be sine theta equals 0.04. Cool? Right. The driving force produced by the locomotive is 450,000 newtons, which means it's moving forward. Let's talk let's talk about locomotive first. I'm going to draw a locomotive here, just a locomotive. Because drawing all the forces, up, down, here, and same for the locomotive as well, is going to be quite very messy on a single diagram. So I'm going to make this diagram shorter, and I'll move it to the side. Okay, let's talk about locomotive right now. Locomotive has a driving force. Of course, if it's taking the coach in the downward direction, so driving force will be in this direction. The driving force produced by the locomotive is 450,000 Newton. Pretty big numbers. 450,000. And their resistances to motion, 12,000 Newton on the locomotive. So, of course, if the motion is, downward, let's say this is the direction of motion, then the friction will be against the motion, right? So that is going to be 120,000 Newton friction. And 15,000 Newton is the friction on the coach. The coupling between the locomotive and so this tension, this is the coupling between the locomotive and the string thing that's connecting the locomotive and the coach. If I'm talking about the locomotive, remember the direction of the tension, the direction of the force of tension is always away from the object. So in this case, this would be the direction of tension for the locomotive. And I'm going to zoom in. And this is going to be, so that's the direction of the locomotive tension, and the direction of tension for the coach is going to be in the opposite direction. Make sense? So if you're talking about the locomotive, as you're standing on locomotive, then the tension will be away from the locomotive. But if your point of view is coach, then the direction of tension will be away from the coach. Make sense? So if I'm talking just about the locomotive, the direction of the tension will be away from the coach. Okay, I'm not drawing the inclined plane one more time. Right. Find the acceleration of we need to find the acceleration of the locomotive. So we need to find out the value of A, and the tension in the coupling. We need to find out the value of tension as well. Let's see. Because the motion is in the downward direction, so we'll do the net force first. Remember the formula that we always use for the net force? Remember, whenever we have net force is equal to supporting forces minus opposing forces. Always. That's our forever formula for net force. Supporting forces minus opposing forces. So for the supporting force, what do I have for the supporting forces? Net force, the formula for net force is equal to MA. What are the forces supporting the motion? I think the force is, oh, I think we also missed one thing. Weight of the locomotive, right? We know that weight has a component mg cos theta in this direction, and the direction, this would be the direction of the weight mg sine theta. You know how it works, right? Um, on this is the direction of weight of the locomotive mg, right? And this component is mg cos theta. Because it's moving downwards, so a plane is this way, so this direction is going to be mg sine theta. Cool. So the other the other force that is really helping supporting force to the locomotive is mg sine theta as well. I'm going to put that in there. So 450,000 plus mg sine theta. What's the opposing force? There are two opposing forces. One of them is friction to the motion, that's given, 120,000. And tension is also opposite. The direction of tension is also opposite to the direction of motion. Let's put in the numbers. So M, for the locomotive, what's the mass of the locomotive? The mass of the locomotive is 240,000. Let's put that. Big numbers, 240,000. A equals 450,000 plus, again, mass is 240,000 times G is 10. And we know that sine theta is going to be 0.04. We just worked it out. 0.04 minus 120,000 minus tension. Okay, so that's our equation for the locomotive. Let's rearrange it. Let's make it a bit neat. Let's solve it as well. So I kept this one the same. It's going to be 450,000 plus. Let's multiply all of these. So if I were to multiply all of them, and once I subtract it with this as well, altogether I'm going to get 426,000. Okay, so I'll just write 426,000. 426,000 minus t. Um, let's move t over to the other side. So that becomes 240,000 plus t equals 426,000. Okay, that is my first equation. For A, it's going to be A as well. A plus t. That's equation number one. I can't really do much with it because there are two variables. There's acceleration, I do not know. There's tension, I do not know. So there is nothing I can work out from here. That was about the locomotive. Let's talk about the coach. Right, here is the coach. So remember, we're talking about a coach. Coach is being pulled by the locomotive, right? So the direction of tension for the coach is going to be away from the object, which is this. Okay, let me draw this first. So this tension of the on the coach. Then there is, if we talk about the weight of the coach, there are two components to weight, which is mg cos theta and mg sine theta in this direction. I'm not going to draw the rest. And what's the force that is opposing the motion? And that is, the force that's opposing the motion is 115,000. These are the resistances to the motion. So backward is 15,000, right? Let's work for coach. So MA, the resultant force, I don't think I have to write this formula again, this one. I'm using this frame formula. Net force is equal to supporting forces minus opposing forces. We know that the coach is moving downwards, right? Which means that supporting the forces that are supporting the motion are mg sine theta plus t, and the force that's opposing the motion is 15,000 Newton. Let's put in the numbers. So what's the mass of the coach? The mass of the coach is 36,000. Right, so I'm gonna put 36,000. I do not know the acceleration, so I'll just write it as, where did it go? Okay, A equals, that's 36,000 for the mass. For G, I'm gonna put 10. And we know sine theta. Sine theta is 0.04, right? Here, 0.04. So 0.04 plus, I do not know the tension, and minus 15,000. Let's work it a bit. So that is going to be 36,000 A. And if I were to do the maths, that is, if I were to multiply all of these three numbers, if I take away 15,000 as well, I'll be left with negative 600. So T minus 600, right? I'm going to move T over to this side. So that is going to be 36,000 A minus T equals negative 600. And that is my equation number 2. So pause and try. You have two equations, equation number 1 and equation 2. You can either use substitution, solve them simultaneously to find out the value of T and A. You can either solve them simultaneously, or you can use substitution as well. I'm going to use elimination. I'll just add equation 1 and 2. Adding 1 and 2 because I find it easier somehow, sometimes. So that is 24,000, 240,000 A plus T equals 426,000, right? And if I were to add in the second equation, which is this one, 36,000 A minus T equals negative 600. Let us work it out. So the reason that I chose addition, because I can tell that this thing pretty neatly cancels out. Let's do the math. So 240,000 A minus 36,000 A, I'm gonna get, I'm actually adding them, so I'm gonna get 276,000 A equals, if you do the math over here, you're gonna get 4,250, 425,400. And if I do the math, 276,000, I'm gonna get 1.54 meters per second square. Sounds pretty. I know the numbers are really big, which means you have to be extra careful while dealing with these numbers. Okay, if you miss out on a zero, you're done. Not going to get the right answer. We needed to find the value of A, which we just did. Sorry, to find the acceleration of the locomotive. Yes, we just did. Now we need to find out the tension. And tension shouldn't be a problem. You can put this either in equation 1 or in equation 2. I'm going to put this in equation 2 in this one. So put A equals 1.54 in equation 2. Equation 2 is 36,000 minus T equals negative 600. And A, there's A as well. So instead of A, I'm going to put 1.54 minus T equals 600. I think you can work out the T, which is going to be, if you do the math, you could just get 56,040 Newton. 56,040 newtons. That is the magnitude of the tension force. I know, pretty long, yes, and this is why this is for 5 marks, but you get the idea. It is simple breaking down, simultaneous solving, and nothing else. All right. I hope it makes sense. Question number 3. A car of mass 14,000 kilogram traveling on a straight horizontal road accelerates uniformly from a speed of 15 meters per second to a speed of 20 meters per second. over a distance of 175 meters. So you know U, which is 15. You know V, which is 20. You know distance, which is 175 meters. Find the time taken, so you need to find out the value of time. Which equation of motion should I use? Well, if you open the formula book, I think you're given an equation which is equals to times t. This is an equation of motion you're given in your formula book. I think I know everything. I'll just put in the numbers. So 175 equals u would be 15, and that is 20 divided by 2, multiply by t, and t is going to be 175 multiply by 2 divided by 15 plus 20. And if I were to rearrange it or solve it altogether, I am going to get the value of t as 10 seconds. Pretty easy. It looks like a warm-up question. Moving on to the next part of the question, which says there is a resistance force of 800 Newton to the motion of the car. So let's say the car is moving in a certain direction. For example, let's say the car is moving in this direction. Let's say this is a direction of motion, right? Then, in that case, use the energy method to find out the average power of the car's engine as the speed increases from 15 meters per second to 200 meters per second, 20 meters per second. So the motion is in this direction. The resistance to motion would be, of course, in this direction, which is going to be 800 newtons. And forward, you have the driving force. I'll just call it DF, yeah, or FD. It doesn't really make a difference. Makes sense? Now use the energy method. Now think about this for a while. Think about in terms of a car, how a car moves. When a car moves, of course, the power engine exerts some power, and engine, of course, does some work on the car, and the car work is spent in two ways. Work is spent in increasing the kinetic energy of the car. So, for example, the speed increases from 15 to 20, which means the kinetic energy is essentially increasing as the speed increases. Also, there is a resistance force, right? So there is a resistive force which is pulling the body in this way, and you're trying to move ahead. So there is also some work done to move the car against the friction. So I'll say work done by the engine is equal to that is converted into increase in the kinetic energy of the car plus work done against friction. You exert some, you do some work to push the car forward against the resistive force. Okay, so that's the only equation that you need to solve this 4-mark question. Work done by engine. Okay, you're familiar with the work energy theorem, right? Energy is converts into work, is converted into energy. So work done by the engine is equal to increase in kinetic energy of car plus work done against friction. Work done against friction. Okay, now we know the formula for all of these. Uh, we know the formula for power, which is equal to work done divided by time. If I were to isolate W, I can write it as power multiplied by time. Work done is equal to power multiplied by time, which I can put over here. Power multiplied by time is equal to increase in the kinetic energy of the car. So increase in kinetic energy would mean kinetic energy final minus kinetic energy initial. This is kinetic energy final. I mean, this is, you can use this speed to work out the kinetic energy final minus kinetic energy initial. So kinetic energy, um, kinetic energy final minus kinetic energy initial plus work done against friction would be force into distance. All right. Now, we know that the car moves 175 meters, right? So let's put numbers from the top. Power, we need to find out power, average power. So this is my unknown over here, right? The time it takes is, we just worked out the time, which is 10 seconds. So I'll power multiply by 10 is equal to kinetic energy means half m vf square. This is the final velocity minus half m vi square. I'll put in the numbers in the next step. Plus force, we're talking about the friction force, which is 800 Newton, this one, and the distance traveled is 175 meters. Okay, now I'll very carefully, this is going to be 10p. If I were to take a half m common from both of them, so that is, or you can just put in the numbers directly. I prefer my things simplified. So, final velocity square, you can write it as, v squared minus u squared, if that's what you're familiar with. V squared minus u squared plus 800 times 175, that's going to be 140,000. Right? And you know the final velocity, which was 20, and you know the initial velocity, which is 15. Put in the numbers, and I'm sure, and you have to put in the mass as well. And the rest is just calculation. 10 times p is equal to a half. Mass of the car is, what's the mass of the car? 1400 kilograms. So I'll put 1400 here. 1400 times the final speed was 20 meters per second and initial speed was 15 meters per second. So I'll put 20 squared minus 15 squared plus 140,000. 10p would be equal to, so 1400 divided by 2 would be 700 times 20 squared minus 15 squared. Altogether, when you do the math, you're going to get 122,500 plus 140,000. So that is going to get me, P would be equal to, if you do the math, you should get 26,250 watts. Or you could just write W. That should be your answer. Right? I just added both of them and divided by 10. I hope it makes sense, right? So if you carefully, this is a very common question, energy method. Okay, let's pause and reflect what we did over here. We used the energy method, which is, you can think about it as a budget, right? So this is the budget. I mean, this is the provided energy, right? And this is where the energy is spent. So the amount of energy provided was, by the engine, worked in by the engine, and that is spent in increasing. So this is expense one, which is increasing the kinetic energy of the car, plus another expense is work done against friction, that is expense two. Okay. And the rest is just maths. We will put in the numbers into the formula and we isolate P, and that's how we got our answer. I hope it makes sense. So that was for 4 marks. I think not so bad, not too bad for 4 marks. Find the steady speed that the car could maintain. So when we say steady speed, which means the speed is neither increasing nor decreasing, which means speed is constant, right? If the speed is constant, the acceleration is zero. When the acceleration is zero, net force is equal to zero. So we concluded so many things just by looking at this word, phrase, steady speed. Steady speed means speed is not changing, acceleration is zero, which means net force is zero, which means forward forces, uh, forces on the up is equal to forces on the down, and forces on the left is equal to forces on the right. The car could maintain on horizontal load if the engine is working at the power found in B1. So basically what it's saying is if the engine is working at this power, which is 26 to 50, right? What is the force that the car could maintain when the forward force and the backward force would be equal to zero, such that the forward and the backward force is zero? We know the backward force is 800 newtons, right? So if we want to maintain a steady speed, we have to make sure that the forward driving force should also be 800 Newton. Okay. So this is something that I inferred from this thing. Net force, if I want net force to be zero, which means backward force must be the same as the forward force. So, which means the driving force, I would say FD is equal to 800 Newton, right? So if we know the power, we know the driving force, we could work out the steady speed. So using the formula for power, which is equal to F multiplied by V, if the power is 26,250 and the driving force is 800 Newton, what will be the velocity? Well, it's just simple division. 26,250 divided by 800, and you will get the velocity, which is going to be 32.8125. 32.8125 meters per second. That is going to be the steady velocity if the net force is zero. Right, let's move on to the next bit. And this is particularly interesting question. So this concept, this question combines vertical motion plus law of conservation of momentum. You have to be very, very careful with this one. A particle P of mass zero point 0.1 kilogram is projected vertically upwards with a speed of 30 meters per second from horizontal. Okay, draw a diagram alongside as you read the question. Okay, you may need to, and it is preferred to draw a diagram with a pencil so that you can make adjustments as you go. This is a horizontal ground, and this is object P, and that is projected vertically upwards with the mass is 0.1, and is projected vertically upwards with the speed of mm, mass is equal to 0.1 and projected vertically upwards with the speed of 30. And here we go. At the same instant, a particle Q of mass zero point 0.4 kilograms. So we have a bigger particle, which is a mass of zero point 0.4 kilograms, is projecting vertically upwards with the speed of 10 meters per second from a height of 15 meters above the ground. So we have a certain height, and from a certain height, we're projecting another body, which has a mass of, this is projected from the ground. So this is going to be a little over here. And from a height of 15 meters, another object, let's call this object Q. This object is bigger because the mass is uh, 0.4 kilograms. And this is projected vertically upwards with the speed of 10 meters per second. I'm not going to put in the units. 0.4. With a speed of 10 meters per second at a height of 15 meters above the ground in the same vertical line. So they're in the same vertical line. I've drawn them differently, but essentially on the same vertical line. I could just draw on top of them, which is going to look messy. So I'm just going to draw them right next to each other. But they are in the same vertical line. Right. Uh, Find the height above the ground at which P and Q collide. So the height at which P and Q would collide would be the same vertical height above the ground, right? Let's say that height for particle P, that height is going to be S, right? So for particle P, that height is going to be S, but it means collision, where collision happens, that is the points where the two particles meet each other, that is the same distance above the ground, right? I hope it makes sense, because it's going to be a single point that the particles will meet, and that is going to be the same distance above the ground. For particle P, it is going to be SP, right? Which means distance covered by particle P. But for particle Q, it is going to be distance Q plus 15, because the particle Q was already 15 meters above the ground. Okay, so if it covers, let's say, a distance of 2 meters, that is going to be from the ground, it is going to be 2 plus 15. Okay, now let's use the formula. Let's use the equation of motion, which equals using equation of motion, which is S equals ut plus half at squared. Let's use this equation of motion in this one. So it's going to be ut plus a half at squared, and I'll use the same equation of motion for SQ as well, which is going to be ut plus a half at squared plus 15. Okay, now I'm not putting any subscripts because for in this equation I'll put in the values for particle P, and in this equation I'll put in the values for particle Q. So what's the initial velocity for particle P? It is 30, and I do not know at which time will they collide, right? So when they collide, for example, let's say the motion starts at t is equal to 0, right? After how much time will they collide? I do not know. Okay, so I'll keep the time as t. I'll keep the time as t plus a half. So both particles are moving upwards. Because both particles are moving, whenever the particle is going upwards, the acceleration is downwards, right? So if the particle motion is upwards, if the motion and acceleration, gravitational acceleration have opposite directions, g is taken as negative 10. All right, acceleration is gravitational acceleration, which is negative 10. T squared is equal to, let's talk about particle Q. Particle Q is also moving upwards with initial speed of 10 t plus a half. Again, particle Q is also moving upwards, so which means that it's also going to be negative 10. The value of A is also going to be negative 10 t squared plus 15. Okay, now this is 30t plus negative 10 divided by 2 is going to be negative 5 t squared equals 10t negative 5t squared plus 15. 5t squared and 5t squared will cancel out from both sides, and I'll be left with 30t minus 10t is equal to 15. 30 minus 10 is going to be 20t equals 15. T is going to be 15 over 20, which is going to get me t equals 0.75 seconds. So 0.75 seconds is the time after they were shot. 0.75 is the time for collision. That's, I mean, after being shot vertically upwards, at t is equal to 0.75, they collide with each other. Now, whenever you feel like whenever you're done with one part of the question, it's totally okay to feel stuck and ask the question to yourself, what's next? So when you're done, half the question, go back and read what you were actually trying to find. We were trying to find the height above the ground. So I think it should be cool. We know the time at which they collide. We can put it in second equation of motion to work out the distance traveled at when time was equal to 0.75 seconds, right? So at t is equal to 0.75 seconds, distance traveled by, uh, because we're talking about height above the ground, so we'll take the distance of p. Distance traveled by particle p would be s equals ut plus a half a t squared. So it's going to be, it was shot at 30. The initial speed was 30 because it was shot at vertically upwards at a speed of 30, right? And now at time 0.75 seconds, the gravitational acceleration was negative 10. At time 0.75 squared, I think when you put all of this in the calculator, you're going to get 19.6875 meters. That is the distance above the ground at which the particles collide with each other, right? So when the P was shot vertically upwards and Q was also shot vertically upwards, this is the time at T is equal to uh, 0.75 is the time when the particles P and Q collided. particles P and Q collided. Right, so that was for 4 marks. I think that wasn't too bad. So let's pause and reflect what we did. We had two particles which were shot vertically upwards. One particle was shot at from the ground, the other particle was shot from a height above the ground. So um, to work out the distance traveled from the ground, I work for the time. At what value of time did they collide? So for that, I used this equation, which was the distance traveled by the distance traveled by both the particles should be the same, right? So distance traveled by P would just be SP, but the distance traveled by particle Q would be SP plus 15 because it was already 15 meters above the ground. I used this equation to work out the value of time, and I found out that they collided at time t is equal to 0.75 seconds. Then I used this time to work out the vertical distance traveled. I hope it makes sense. Next, when particles P and Q collide, they coalesce. Coalesce means they combine together. So the combined mass of PQ would be zero point 0.1 kilogram was the mass of the particle P, which was given over here, and zero point 0.4 is the mass of particle Q. So combined mass would be 0.1 plus zero point 0.4. Altogether the mass is 0.5 kilograms. When particles P and Q collide, they coalesce. So we have a big particle which is PQ. It is, it's a combination of P and Q. Find the speed of the combined particle at the instant that it reaches the ground. Okay. Now approach this problem very, very carefully. First of all, we had particle P and we had particle Q, right? They collided at time equals to 0.75 seconds, right? So there's going to be a certain velocity before collision, and there's going to be a certain velocity after collision, right? Combined velocity after collision. So first of all, I'll find out what were their individual velocities before collision. Okay, let's calculate their individual velocities before collision. Like before they collided, what were their individual velocities? So let's work that out. I'm gonna put this over here. So before collision, let's talk about particle P. So velocity of P was V equals U plus AT. Let's use this formula and try to do it in a single step. So final velocity is equal to initial velocity. The velocity at which it was shot was 30 plus because it was shot vertically upwards and gravity acts downwards, so it's going to be negative 10 times t. Time is 0.75, so the velocity you're going to get is 22.5 meters per second. Let's talk about particle Q. Velocity of particle Q, we'll use the same formula, U plus AT, and final velocity would be, so it was shot at the initial velocity of 10, right? We're given that. Particle Q was shot at an initial velocity of 10. It's given over here, right? So 10 and plus minus 10 is the gravitational acceleration acting downwards, and we want to find out the velocity at time equals to 0.75, so I'm going to get 2.5 meters per second. So these are their velocities before collision, right? So let's apply law of conservation of momentum to find combined velocity after collision. After collision. Okay, so we'll apply the law of conservation of momentum very, very carefully. We'll use m1u1 plus m2u2 is equal to, because the bodies are coalescing, which means their masses are added and they will have a final velocity of v, right? Let's put in their masses. So we know that this is about particle P and this is particle Q. Particle P has a mass of 0.1, right? And before collision, this is their velocities before collision. Before collision, the velocity of particle P was 22.5 plus the mass of particle Q is zero point 0.4 and the velocity before collision was 2.5. Their masses are added, so zero point 0.1 plus zero point 0.4, and we need to work out their final velocity. I think if you were to do the maths on it, all you have to do is simply multiply them, multiply this, add them, divided by zero point 0.5, and you will get the final velocity, which will be 6.5. So that's the velocity of PQ after collision. Velocity, I'm going to name it as velocity PQ, and you're going to get 6.5 meters per second. That's the combined velocity after collision. Okay, so that was first part of the question, and we have this figured out. Now, the next part of the question says, and we have to be very careful with this. Now we have a bigger mass, which is PQ, which is P and Q combined. It has a velocity of 6.5 meters per second. It is right now at the height of 19.685. That's what we worked out in the last question. Right now it is at the height of 19.6875. Is that? Yeah, 6875 meters above the ground. Now, of course, it has a certain velocity, so it's gonna go up, right, a little, and then it's gonna come back and hit the ground. What we are required to do in the question is, what is the speed of the combined particle at the instant when it reaches the ground? Which means we need to find out the velocity at this point. Okay, so how would you do this? Well, one way of doing it is uh, the displacement between this point and this point is 19.6875, right? So you could simply use the formula, which is, displacement equals displacement is equal to uh, final velocity at this point. It's not zero. So you could simply use the formula for displacement, right? Which is S equals, I think I'll use a different approach. First, it's gonna go up, right? So we'll see how much does it go up before, because if it reaches at the maximum height, it's going to have a velocity of zero, right? Once it reaches a maximum height. So first we'll calculate this distance. How far does it go up before taking a turn, right? And let's work this out. So how far does it go up, which means what will be the S when I'll use 2as equals VF square minus, sorry, V squared minus U squared. I'll use this formula to calculate how far up does it go. If the particle is moving upwards, the acceleration is -10. We need to find out S. Final velocity at the top is 0, and initial velocity while it is at this point is 6.5 squared, right? So S is going to be 6.5 squared divided by -20, and S is equal to the amount of distance traveled is 21.8. Sorry, 2.115. My bad. 2.1125 meters. So this distance is 2.1125 meters. What is the total distance from the top? I'll add both of these numbers, which is 19.6875 plus 2.1125. I'll use this distance and I will use the initial velocity is 0, right? So it started from 0. What will be the final velocity as it hits the ground? So I'll use this formula again, which is going to be 2as equals vf squared minus, sorry, v squared minus u squared. So 2. So the particle is, at this point, during this part of the motion, the particle is coming downwards. We know the acceleration is also acting downwards. So value of g will be taken as positive 10. Okay, be very careful with that. S would be the amount of distance, which is 19.6875 plus 2.1125, because that's the amount of distance that it traveled, equals v squared. This is what we need to find out. And initial velocity at the top is 0. Okay, so I'll just add both of them, and v squared would be equal to uh, 2 times 10 times 21.8 when you add them, and once you multiply and square root them, you're going to get 20.9 meters per second altogether. The speed at the bottom. So that is your answer. 20.88, which will almost be equal to 20.9 meters per second. Okay. Now let's take a moment and reflect on what happened here. Okay. Um, we had two particles, particle P and particle Q, right? They collided at a height of 19.6875 meters above the ground. First things first, we worked out their velocities before collision, right? Then I applied law of conservation of momentum to work out their velocity, combined velocity after collision, right? Then I used simple kinematics to work out the speed before reaching the ground. So the particles combined, they went a little up and they hit the ground. So first we worked out how far up did they go. And for example, that distance turned out to be 2.11. Right? And then I added that mass, that distance with, added both of them to get this distance, total distance. And I then used this distance to work out the velocity at the bottom. So that's it for this question. Let's move over to the next part of the question. A block of mass 5 kilogram is being pulled straight down a line of greater slope. So is being pulled down, right? So the motion is in the downward direction. This is the direction of motion. Line of greater slope through the rough plane, which means the plane has a certain friction by a force of magnitude 20 newtons. Right. The plane is inclined at an angle of 10 degrees to the horizontal, and the force 20 newton acts at an angle of 35 degrees above the line of the greater slope, which means the force is acting at an angle of 35 degrees. The coefficient of friction between the block and the plane is 0.4. The speed of the block when it passes through the point O, let's say it is right now at point O. It is passing through point O. Okay, at this point, the speed is equal to 2 meters per second. Find the speed of the block when it has moved up, find the speed of the block when it has moved 3 meters down the plane from O. All right, so we have an inclined plane in front of us, and I'll take the snapshot of this inclined plane. I'll bring it downstairs, actually take a better screenshot. Yep. and I'll put it over here. Right. Now let's resolve the forces into components. So at this point, if I were to resolve this force into components, I'm gonna have uh, down the slope, I'm gonna have mg, the weight of the body, goes 10 degrees because that's the inclination of the plane, right? Up the plane, I'm gonna have r, right? Because the motion is in this downward direction, right? This is the direction of motion, right? So which means the direction of friction is going, since the body is already moving, which means it has already overcome its maximum friction. So value of friction is going to be mu r, force of friction. And the body is being carried with a force of 20 newtons. So um, so it's going to be now let's break down this force into components. So 20 Newton, this part of the force in this direction is going to be 20 cos 35 degrees, and it's going to have an upward component, which is going to be 20 sine 35 degrees. I think that's it. There are no more components. So the motion is in this direction, right? Which means there's going to be net force down the plane, and the body is vertically balanced, which means up the plane is equal to down the plane. Forces up the plane is equal to vertically up the plane is going to be vertically down the plane, which would essentially mean are these forces. R plus 20 sine 35 degrees will be equal to mg cos 10. So um, R, so that is going to be R plus 20 sine 35 degrees will be equal to mg cos 10 degrees. If I were to do the math, I'm gonna get um, mg cos 10 degrees minus 20 sine 35 degrees. I think I should put in the numbers. That's going to be, um, I'll put the numbers in the next step. So mass is 5, g is 10, cos 10 degrees minus 20 sine 35 degrees is going to be 50 cos 10 degrees minus 20 sine 35 degrees. Okay, we found out the value of r. Now, at this point, what I'm going to do is I can work out its value up to 3 decimal places. Make sure that you're working out whatever the values you're working out, or I can keep it like this. I'll keep it like this. And then, uh, because there's a net force, there's motion down the plane, right? Which means that if I'm talking about the net force, it's always going to be forces supporting the motion, supporting forces, minus forces opposing the motion, which means opposing forces. So what are the forces which are supporting the motion? Well, there is a force that's supporting the motion, and that is uh, 20 cos 35. I think there's another force. I forgot to. This is mg cos 10, and this is going to be mg sine 10 in this direction. The other component of the weight, mg sine 10 degrees. All right. Supporting forces are mg sine 10. Mg is 50, right? So that's going to be 50 sine 10 degrees plus 20 cos 35 degrees minus. What are the opposing forces? The opposing force is just mu r, the maximum friction, minus mu r, which is the maximum friction. Div that's the net force, and below the net force is equal to ma. right? And once I put in all the numbers, that's going to give me the acceleration. So the mass is 5. So that's 5a is equal to 50 sine 10 degrees plus 20 cos 35 degrees minus mu. Mu would be 0.4. The coefficient of friction between the block and the plane is zero point 0.4. So I'll put the value of mu 0.4. And in place of r, I'm going to put its value, which we worked out over here. So that is going to look like 50 cos 10 degrees minus 20 sine 35 degrees. That's that. Let's do some simplification before we do the maths on it. Well, I'll divide everything by 5 to begin with. And I'm going to do the simplification at the top. 50 sine 10 degrees plus 20 cos 35 degrees minus zero point 0.4 times 50 would be 20. That's going to be 20 cos 10 degrees, and minus is plus. 0.4 times 20 is just 8. So 8 sine 35 degrees. We have 50 cos 35 degrees. 50 supporting forces is 50 sine 10 degrees plus 20 cos 35 degrees minus 20 cos 10 plus 8 sine 35 degrees, everything divided by 5. I'm going to put in the calculator all at once, and I'm going to get almost acceleration of 1.991 meters per second square. Now, let's get back to the question. Question was essentially asking that find the speed of the block when it has moved 3 meters down the plane from point O. So the problem now simplified into this. That's a plane, right? You have a block passing through, let's say this is point O. At this point, it has what's the velocity at this point? Its initial velocity is 2 meters per second. 2. Its initial velocity is 2, and it is moving down the plane with the acceleration of 1.99 meters per second. And it traveled how much down the plane? It traveled 3 meters down the plane. So it traveled a distance of 3. What will be the value of final velocity? I think it's a simple third equation of motion question, which is simply 2as equals v squared minus u squared. Acceleration is 1.991. Distance traveled is 3. Final velocity, we need to work out the final velocity. And the initial velocity when it was passing through point O was 2. So if I were to work it out, I'm going to get v equals square root. I'm going to send 2 over to the other side. So 2 times 1.991 times 3 minus 4. This is the math you can do by yourself. And you're going to get 3.99 meters per second. 3.9 and 2 maybe meters per second. That is going to be the final velocity after sliding down 3 meters. So that was a multi-step question. And let's pause and reflect what we did over here. We had a box, right, that was sliding down. We resolved the forces to work out the value of acceleration, which turned out to be 1.991 meter per second square. And we used that velocity. We used the value of acceleration to work out the final velocity when s was 2 meters and the initial velocity was s was 3 meters, I think. Yeah, s was 3 meters and the initial velocity was 2 meters per second. So that's it for question number 5. I am hoping that it makes sense. Let's move on to question number 6. A particle starts from rest at point O. So it starts from a certain point, which is O. The acceleration of the particle at time t seconds after leaving point O is a meters per second. So a would be the acceleration. Find the distance that the particle travels from O until the time at which its acceleration is zero. So just by reading the question, I think the first thing I can do is, this is acceleration, right? So, and the other variable over here is time. So I'll put acceleration is equal to zero. I'll find out at which time acceleration was zero. That's the first thing I'll do. At which time acceleration was zero. Okay. So in place of A, I'm going to put zero and I will work out the value of time. So 1 would be equal to 2 divided by t plus 1 to the power, at the top it was negative 1 by 2, at the bottom is going to be positive 1 by 2. And I'm going to multiply it by both sides, which cross multiply, which is going to get me t plus 1 to the power 1 over 2 equals 2. And then I will square both sides. So that's going to get me t plus 1 equals 4. T equals 4 minus 1, t equals 3. This is the time, I mean, at t is equal to 3, the particle had acceleration of 0. If you carefully notice one thing, a particle starts from rest, which means, can I say that it's starting from rest? So just by reading this part of the, I can say that time t is equal to 0, which means when the particle was starting out, v was also equal to 0. Okay, so these are the teeny tiny things that we have to look for because we're going to use them in our subsequent working. Okay, now the most important thing that we have to look for is we're given the acceleration and we need to find out the distance. So what is the relationship between acceleration and distance? We know that we have three variables, s, v, and a, right? And going in this direction, we go in this direction by differentiation, right? We differentiate to move this direction. And if we have to go backwards, we integrate. Going backwards is integration. All right. So I'll have to integrate twice because this is where I'm standing right now. Right. I will go to velocity first and then I'll go to distance. So we know that acceleration equals 2 times t plus 1, 2 times t plus 1 to the power negative a half minus 1, right? So if I were to integrate both sides, integrating acceleration is going to give me velocity. And let's integrate this side, 2 times t plus 1 to the power negative a half minus 1 dt, right? And let's integrate it. So if I were to integrate it, I'm going to get 2 t plus 1 to the power negative a half plus 1 divided by negative half plus 1 minus, if I were to integrate 1, I'm just going to get t plus c. Let's simplify this a bit. So that's going to get me 1 minus 1 by 2 is 1 over 2 is in the reciprocal. If I were to multiply it to the top, that is going to be 2 multiplied by 2 by 1, t plus 1 to the power 1 minus a half is just a half minus t plus c, right? Now, I have the velocity, but there's a slight problem, and that is I have the value of c. So my expression for velocity is incomplete. Okay, let me simplify this a bit. That is going to be 4t plus 1 to the power a half minus t plus c. Right, how do I find out the value of c? Well, I pointed out an initial value I pointed out an initial value, which was when t is equal to 0, velocity was also equals to 0, right? So I'm going to use this initial value, and that is at t is equal to 0, v was also equal to 0. So I'm going to put, for v, I'm going to put 0 equals 4 times 0 plus 1 to the power a half minus 0 plus c. And that's going to get me c equals -4 after a little solving. So my expression of velocity is now complete. We know that velocity equals 4 times t plus 1 to the power a half minus t. Instead of c, I'm going to put a 4. That's the expression for velocity. Now, just writing out velocity is not enough because we need to get to the value of distance, right? So going from velocity to distance is simply integrating. So I'm going to integrate from this point onwards. I'm going to integrate velocity. Sorry, distance is equal to integration of velocity, and which is 4 times t plus 1 to the power a half minus t minus 4. And now if you carefully notice, this is integration in dt, right? So I can put in the upper and lower limits for distance, for time, right? Time starts from 0. And at what time was the acceleration 0? There was time. The time at which the acceleration was 0 was time t equals 3, right? So lower limit would be 0, upper limit would be 3. And I think this is just a simple integral that you can solve. First of all, I'll work out the integration, which is going to be 4 times t plus 1 to the power 1 over 2 plus 1 divided by 1 over 2 plus 1 minus t squared by 2 minus 4t, and I'm going to apply the limits, right? Let's simplify this a bit. So a half plus 1 would be 3 by 2. 3 reciprocal of 3 by 2 is 2 by 3. T plus 1 to the power of 3 by 2 minus t squared by 2 minus 4t. I think let's put in the limits, right? Upper limit minus lower limit. So distance travel is going to be 4 times 2 is 8 over 3. I'm going to put the upper limit first, which is 3 plus 1 to the power of 3 over 2 minus 3 squared would be, I'll just put in 3 squared by 2 minus 4 times 3. That's the upper limit, which means wherever you had a t, at first I've put a 3, and in the next upper limit minus lower limit. So for the lower limit, wherever there is t, I'm going to put a 0. So 8 over 3 times 0 plus 1 to the power of 3 over 2 minus 0 minus 0. Because they're both t. I think this is, from this point is just math. So 8 over 3, 4 plus 1 to the power 3 plus 1 is 4 to the power 3 over 2, which is just going to be 8. I'll just write it as 8. Times 8 minus 9 over 2 minus 4 times 3 is 12 minus 8 over 3. And I'll let you do the maths. I'll let you put this in the calculator. And altogether, you're going to get 64 over 3 minus 9 over 2 minus 12 minus 8 over 3. You're going to get 13 over 6 meters. That is your answer. In my opinion, the working was a little too simple for 8 marks. Okay, so this is, we've sort of got a leverage over here that um, this question wasn't too bad, put it simply, right? And let's pause and reflect what we did over here. We were given the expression for acceleration, right? We first things first, we found out the value of t at the point at which, the value of time at which the acceleration was 0, and that point was t equals 3. Next, I integrated acceleration to get to the velocity. Then I used initial value to work out the value of the constant, which was 4 and that completed my expression for velocity. Then I integrated velocity again, to work out the displacement or the distance traveled. And so I integrated this expression for velocity again. I've put in the limits for time from 0 to 3, and that got me the value of distance, 13/6. Right, I'm hoping this is the last question. It better be. Yes, this is the last question. Four coplanar forces of magnitudes 20 Newton and 30 Newton, 20 Newton, 30 Newton, 15 Newton, and 25 Newton act at a point P in the directions shown. So if you have these forces, 20, 15, 25, and 20, different angles, they're working at different angles. The forces act in a vertical plane. The resultant of these forces have a magnitude. So this is the overall resultant, which is S, and it is working at an angle of a certain angle of alpha degrees from horizontal. Find the value of S and the value of alpha. Let's work it out. So I'm going to copy down this diagram to our working space, and let's break down the forces into horizontal and vertical components. Let's make it smaller and let's break down the forces. So I'm going to use different colors for different forces. 30 Newton, this component of 30 Newton would be 30 cos 30 because it's along the angle. The upward component or the vertical component of the 30 Newton force is going to be 30 sine 30. That is the first angle, first force. 15 newtons, this direction of 15 Newton is going to be 15 cos 45, 15 cos 45 degrees, and downward we'll have 15 sine 45 degrees, right? I mean, along the angle inward. Um, for this one is going to be, so in this direction, force will be, in this direction, the force will be 20 cos 20, and upward would be 20 sine 20 degrees. Okay, let's write down all the forces in the upward direction. Let's write down all the forces in the downward direction. Let's write down all the forces in the to the left, and let's write down all the forces to the right. Upward forces are 20 sine 20 plus 30 sine 30. 20 sine 20 plus 30 sine 30 degrees. Downward forces are 25 plus 15. Oh my God. 25 plus 15 sine 45 degrees. Forces on the left, we mean, by forces on the left, we mean these forces. We only have one force on the left. That is 20 cos 20. So forces on the left are 20 cos 20 degrees. Forces on the right are 30 cos 30 plus 15 cos 45. Forces on the right would be 30 cos 30 degrees plus 15 cos 45 degrees. So these are all the forces to the upward direction, downward direction, left and right. So I think let's evaluate them. So while we're doing the intermediate working, make sure that you're not doing the rounding error. Make sure that you're not doing premature rounding. So at this point, make sure that you are writing your answers at least up to 4 decimal places. You can round by the very end, but make sure that you're not doing premature rounding. So 20 sine 20 plus 30 sine 30, if I were to do that, I'm going to get 21.8404 newtons. For downward forces, if I were to add all of them, I'm going to get 35.6066. Forces on the left would be 18.7938, 7938, and the forces on the right is going to be 36.5873. 36.5873. Right. Now, carefully notice what is going to be the resultant to in the vertical direction. Take a look at these two forces. Which one is bigger? Of course, we know the downward force is bigger, right? So the resultant vertical would be resultant vertical. It's going to be uh, downward minus upward forces. So this is the resultant vertical, which is down minus up because the downward force is bigger, right? So I'm going to get resultant vertical of, let me do the subtraction. Downward force is 35.6066 minus 21.8404, and the downward force turns out to be, wait a sec. Yeah. So resultant 35.6066 minus 21.8404, I'm gonna get 13.766. Okay, which again the direction is downward, right? So this forces on the downward is 13.766. Let's work out the resultant horizontal. Resultant horizontal. So take a look at the horizontal forces. By horizontal forces, I mean the left and right. Which one is bigger? Forces, I think forces on the right is bigger than the force on the left. So I'm going to do right minus left. Right minus left, which is going to be, right is 36.5873 minus forces on the left is 18.7938. 18.7938. And I'm going to get a resultant of, if I do the math, I'm going to get 17.793. 17.793, and the resultant is to the right. So I'm going to draw it like this. Okay, let me draw the resultants down here. Uh, this tests my patience every time. Let me redraw this. So forces on the right are 17.793. Force in the downward direction is 13.766. Right. Now the entire problem, and a picture this huge boils down to just this. Right? This is the resultant horizontal. This is the resultant vertical. Let's work out their resultant. So the resultant is going to be somewhere over here, right? And which is exactly what we need to find out, which is S, right? This is the resultant, S newtons. Okay, so I think let's work out the resultant by using Pythagorean theorem. S would be equal to square root of 17.793 squared plus 13.766 squared. Once I solve that, I'm going to get 22.532 Newton. That is the first part of my answer. Right. The next thing we need to find out the angle alpha, right? And we know for alpha, we'll do tangent inverse, vertical divided by horizontal. Vertical over horizontal, which is tangent inverse. Vertical is 17.793 divided by horizontal is 13.766. you can, okay, I'm so sorry. Vertical is 13. I did it the other way around. Vertical means downward. So that is 13.766 divided by 17.793. I'm going to get the angle, which is 37 point. I'll do the math actually. So you can also do it on your calculator. Tangent inverse 13.766 divided by 17.793, and I am getting 37.7 degrees. Up to 3 sig figs, that is my answer for alpha. So that's how we are done with the first part of the question, which was, I think, justifiably 6 marks, right? So let's pause and reflect what we did over here. We had a bunch of forces in different directions. Okay, what we did was we worked out their horizontal. We broke down the forces into horizontal and vertical components, right? Then we worked out their resultant horizontal and the resultant vertical. So let's say the resultant horizontal and the resultant vertical. And from there, we worked out their overall resultant. And then we worked out the angle as well. All right. Last part of the question. It says a small ring of mass 0.6 kilogram is threaded on a rough, straight horizontal wire. So we have a rough, straight horizontal wire, which means it's going to be something like this. That's a rough, straight horizontal wire. I'm gonna make it a dotted. So that's a rough, straight horizontal wire. We're placing a ring on a rough, straight horizontal wire. So let's say this is a ring and slip. 4 forces shown in the figure 7.1. So we have all of these 4 forces. 1, 2, 3, 4. All 4 forces act on this ring and are in the same vertical plane as the wire. Like, I don't have to draw all 4 forces. Like, I don't have to draw all the 4 forces and then work out a resultant, and let's see what the result is, because we already have the resultant, right? We know that there is a force of there is a horizontal force of, in this direction, you have a force of 17.793 acting in this direction, and you have a force of a downward force of 13.766 Newton acting in the downward direction. We just worked out these forces, 17.793 and 13.766. Okay, so the point is we don't have to draw 4 forces. And the same vertical plane, the ring starts from rest and it takes 30 seconds to travel a distance of 2 meters along the wire. Okay, so which means the resultant is in this direction. If the resultant is in this direction of motion will be, this is the direction of motion. If this is the direction of motion, you're going to have a force of friction in this direction. Because the ring is already in motion, which means it has already overcome its maximum friction. The maximum friction is mu r. And we will have the normal reaction force R acting vertically upwards. Okay, is there anything left that we need to draw? All right. Of course, it takes 3 seconds to travel 2 meters along the wire. We'll do this, but first of all, we need to work out the resultant force and the resultant acceleration. Okay, so vertically the body is balanced, which means up is equal to down. So if I were to do up is equal to down, I'm gonna get, okay, the ring also has a mass. I think we've got that. The ring also has a mass. So it's going to have a weight of 6 Newton downwards, because mg would be 0.6 times 10 is going to be 6 Newton vertically downwards, right? So I can say that, uh, let's work out the acceleration first. I think we can also do that. So the ring starts from rest, which means the initial velocity is 0, which means the initial velocity is 0, starts from rest. So u is equal to 0, time is equal to 3 seconds, and s is equal to 2. Okay, I'm going to write all the variables, and you can pause and reflect and let me know which equation of motion should I use to work out the acceleration. We know u is equal to 0. We know that s is equal to 2. And we know that time is equal to 3. And we need to work out the acceleration. Right? I think it's pretty simple. We could just use s equals ut plus half at squared. S is equal to 2, u is 0, t doesn't matter because it's going to be 0. 1 over 2, we need to work out the acceleration, and time is equal to 3 squared. So from here, acceleration is going to be 4 divided by 9. All right. Now, let's talk about forces. Let's talk about vertically, it's balanced. So R, up is equal to down. Think about it this way. Up is equal to down. So that is going to be, up is R and downward force is equal to 13.766 plus 6. So altogether, R is going to be 19.766. 36 and 3 is 6, 7, 8, 9. So altogether it's going to be 19.766 newtons. Right. Now, because the motion is towards the right, so let's work out the resultant force. We know that net force is equal to forces which are supporting the motion minus forces which are opposing the motion. Right? So net force, we know that is equal to MA. We already know A as well. Supporting forces, the supporting force is 17.793. That's the supporting force, 17.793 minus opposing force is mu R. Okay, let's put in the values that we know. We know mass, which is zero point 0.6. We know acceleration, which is 4 over 9. We just worked out the acceleration equals 17.793 minus mu. We also know R, which is 19.766. All right. So I think let's do the maths. This is going to be 4 over 15. So if I were to isolate mu R is going to be, I should put in the value of R as well. Mu times 19.766 is equal to 17.793 minus, if you were to deal with the fraction, that is going to be 4 over 15. I think you can work out the maths. And mu is going to be 0.8868, which you can approximate to 3 significant figures. So that's going to be 0.887. That is 3 significant figures, and that's how we are done with this paper. I'm hoping you found the video helpful, and hopefully we'll see you in the next videos. Take care.